Thank you, Amrendra. So I think we should start. Okay. So data science as a career, this this whole session is about what exactly can you expect from data science as a career? What are the different roles in data science? What is the depth and breadth of data science? Like we're just not going to focus on the technical things, but what are the other aspects in data science? And then in each vertical, what are the things that we should be aware about? And then we will see what are the different business use cases that we can solve using data science. So, my name is Manpreet. I am currently working as a data scientist in Microsoft Azure to be particular. So, this is the agenda for today that we have. So, like I said, we're going to discuss different roles in data science, the depth and breadth of data science, and different use cases. So, before we start, just want to give a little introduction about myself. So I started my professional career journey somewhere around 2015, almost 7 years ago. I started in Cognizant as a programmer analyst, then moved and did my MBA from Symbiosis. That's where my data science journey started. Then till now, I have worked in various companies like VMware, Oracle, and currently I'm working in Microsoft. And I've also contributed to open source. I have a Python package, which has around 35,000 plus downloads, one research paper in VMware that I did, and this is about myself. Now, further not wasting your time, let me just move to the next slide where we will see what are the different roles in data science. So data science journey or data science as a field is very vast. Many things can be covered under data science, starting with data analyst, people who understand the data, people who create dashboards. These are the dashboards that tell us facts, truth, that if our sales are going down, it's a fact. If our customers are coming back to us or they are repeat buyers, it's a fact. So they will tell us the facts. They will tell the facts in the form of charts, in the form of reports. So that's the main area that data analysts focus on. Then we come to the second field, which is data engineer. Now, once we have the data, we before we start building the models, we need to make sure that we have the data in the right format. We have the data from various sources that we want to source, and we want to have the data on our platform. For example, platform can be your laptop, platform can be your server. So we want to have that data to our platform. Now that is the job of data engineer. He would source the data from different sources. It can be a daily pipeline, it can be a monthly job where every quarter or every month we are sourcing the data. For example, if we have sales data and if we say that every month I want the fresh data, so every month we're going to refresh it and we will get the latest data. Now that's the job of data engineers. Then come to the data science as a title, which is data science or ML scientist. Now these are the people who would build the models. They will also be somewhere responsible to source the data in some scenarios where it is easier, and to build the models and to understand the business, to understand the domain knowledge, and to solve business problems or product problems using machine learning. Then we have ML engineers. Now, once we have the data, we have analyzed the data and we have found out the truth. We have sourced the data from different sources. Now we have the data on our server and we have built the models. Now, in order to make it a recursive process, in order to make it a deployable thing, we need ML engineers. So these are the people who would deploy our models so that they can become an automated job. Like every month, I don't have to go and source the data again, build the model, then send the score list to the stakeholders. No, I will automate this entire pipeline so that my data gets sourced, my model gets built, and it's get deployed to my platform. Now that is the job of ML engineer. Now here I have actually put certain skills that you would need for these roles, like domain knowledge, programming knowledge, SQL knowledge, ML and statistics knowledge, dashboard knowledge, platform as in cloud, or your company's inbuilt platform, and software engineering. As you can see, Some of them are must. That means that your role should have, you should have these things as a must if you want to pursue this role. Some are good. That means it is good to have these things. If not, then it's okay. And some are NA. That means you probably don't need these things at all in order to be successful in your role. Now, the chart on the right side of the table shows the process of any model. We start with data analysis, we start with sourcing and making the data available, then we make the models, and then we productionize the models. Any questions on this? Feel free to put your question in the chat. I'll keep on taking the questions and answering it. Okay, moving to the next part. This is where we see the data science depth and data science breadth. When I talk about breadth, it's the pillars of data science that will make you successful. So first thing is business knowledge, second is platform and tools, and third is your maths and machine learning. If I talk about business knowledge, whatever business you are in, like if you're solving the problem for salespeople, if you're solving the problem, let's say for a retailer, like you're working in Walmart and you're solving their shelf life problem, or you are in, let's say, Britannia and you're solving their customer churn. So these things, in order to be successful as a data scientist, you need to understand the knowledge, you need to understand the business, what the company is doing, what is their business, what are the customers, what is the revenue, what are the competitors, what is the model of the business, is it a SaaS based or it's a license based. So these are the things that we need to understand. Now second is platform and tools. This is where you are going to build your data, your source, you're going to source your data, you're going to build your models, you're going to deploy them. Everything that you need is platform and tools. Now, by platform, I mean where you're going to work it, and tools, I mean that you're going to use to build your models. So, first thing is cloud. See, these days, cloud is very important. Like, if I go back to, let's say, 4 years, cloud was not that important. People would come and they would make their data on the laptops, and then they would share the final predicted list to the stakeholders in the Excel format. But these days, it's all about cloud. Why? Because it saves our cost, it automates the process, and we have up and running our applications all the time. So that's the reason cloud has become an important platform where we build our models. Now, three main players of the cloud, as you know, are AWS by Amazon, Azure by Microsoft, and GCP by Google. But there are some other starting players like Oracle, IBM. So these are the players who are also emerging. Now, I would not say that you need to know everything. I mean, all these cloud platforms, even if you learn one, that's okay, because you will keep on changing the companies in your next 30, 40 years of your professional career. And it's okay to learn just one, and others you can learn easily as and when required based on your job profile. Now, today, if you're an ex company and they use GCP, you learn GCP, you work on GCP. Once you get a certain knowledge, if you move to some other XYZ company and let's say they're using AWS, then you can easily learn, because the base and I would say the base structure of these clouds are same. It's just some names are different and some UI is different. Other than that, 80% of the things are same. If you can do one thing in one cloud, you 100% can do that thing on the other cloud very easily with zero to with zero downtime. I mean, it'll be very easy for you to learn. Then if you're working on big data, now this will come probably when you're dealing with models like website or digital models or B2C products like Walmart or Flipkart, where you have thousands and hundreds of customers. So if you want to have that big data usage, Databricks is very good. And Databricks has compatibility with almost all the cloud providers, like on Azure, on GCP, on AWS, so you can leverage that. And even if you don't want to learn, Databricks completely, they have a Python version. I would say they have a Python package called PySpark, which is very similar to Pandas. You can easily learn that. That's not tough, but it leverages the distributed computation of Databricks. Then interactive platform, this is where you're gonna code, right? Jupyter Notebook and Jupyter Lab are a few of the famous ones. because it's very interactive. You can, so you can run each line and you can have the output of each line. It's very easy when you want to do some exploratory analysis, when you want to showcase some initial results to your manager, when you want to do some POCs. But when you want to build a production level code, Jupyter Notebook and Labs are not advisable. You should move to VSC or any other editor. So that way you have a production level code. Then programming languages, two of the most famous languages for data science are Python and R, of course. We have languages like Julia and Scala coming up, even Java for now. But I would say more than 60-70% uh, Python is being used. Like in any major company, if you say Python is there. And if I talk about the compatibility from backend and front end, and at clouds as well, Python is the most used language. So I have used both R and Python, but now I have shifted to Python because it's gaining more traction. It has more open source packages and more open source support. Now, SQL is an important part, right? Because we're dealing with data. Uh, doesn't matter how good we are in machine learning, in statistics, in Python, in deployment, in cloud. If we cannot do queries in SQL, we cannot do anything, right? So we are dealing with data. So we need to understand SQL. Now, SQL is a very subjective thing because many companies have their own SQL servers. Either they are using some open source like PostgreSQL, or they have Microsoft SQL, or they have Oracle database servers. So this I would leave up to you and your and the organization that you are in, but a basic SQL would suffice, because most of the times, the syntax are same. It's just some here and there, but the baseline is same. So SQL is very important, and these days, like I said, Databricks has a PySpark version, and you can actually write SQL codes in Python as well using Python using PySpark. And if you don't want to do that, Databricks give you the option to use PySpark, which is very similar to Pandas. So these days, companies are coming with alternatives, where you don't have to mandatorily know SQL. If you know Databricks, you can do the job. But still, for many of, I would say, in many companies, SQL is still preferred. It's very important to understand, not just from data science perspective, but if let's say you are in dashboard or BI role, then SQL is very important. Then these are some important packages that you would normally use, like Pandas, NumPy, sklearn. These three packages probably every data scientist or every data engineer or ML engineer would know, and he would use. And then some advanced packages related to NLP, and your transformers, and PySpark is for Databricks. And there are tons of other packages that you would use, and there is no need to learn these packages. As and when you solve the problem, you can just Google them and you will be good, because nobody wants you to learn all the packages and their syntax, to be honest. I don't know, at least. Then if we move to statistics, maths, and machine learning, this is your core part. Without this, it's very difficult to be successful in data science and ML roles. So basic statistics and basics of maths, people who are from non-medical and engineers, they would easily, it'll be like piece of cake for them. It won't be that difficult because we have done these things in the past. Now, if I talk about ML, there are three types of problems: supervised, unsupervised, and semi-supervised. And in terms of my problems with respect to my target variable, it's classification or regression. As you know, classification is when I have 0, 1, 0, 1, 2, like that, I have a target variable. And for regression, if it's a numerical data, like I want to predict the stock price of X company in the next 7 days, that's going to be my regression problem. Classification can be if my customer will come back to me to purchase the product, yes or no, or if this is the customer gonna purchase this product, yes or no. Like then NLP is where you have different types of problem that you can solve, like classification, text summarization. These days, we don't like to read whole article. Now there's an app called InShots, where you would see that they have very short summary of the news. Now that is the reason, that could be one of the applications of text summarization. Then we have topic modeling. Topic modeling can be, for example, if you want to know that in this particular text, what are the topics that are being discussed? Like topics can be sports, topics can be, uh, you know, movies are being talked, or anything. Then we have keyword extraction. Then there is one other problem is name entity recognition, which is NER, where in the text we find out names, places, people that we want to check. Then we have computer vision. Now, what what I would suggest is that, see, tabular data is one. Like tabular data, you should be aware of, and you should have a good knowledge on solving tabular data problems. Other than that, there are two fields in machine learning. One is NLP, other is computer vision. Now, computer vision is related to images and videos. NLP is related to text. So you can actually master any one of them. It is, the best case if you can master both. But in the beginning of a career, it's actually good to have one extra thing, either NLP or computer vision, along with your tabular data, because many a times you would have text data. Why? Because it's easy to get text data. Plus, people search a lot, people type a lot. So we have a lot of text data out there. We have a lot of images out there. But in order to have a tabular data in a structured format, it's very difficult because it has a cost. Because if we want to have the tabular data, we have to have a proper team that would build the data, that would take the data. But text is readily available. Now, famous algorithms, or I would say, the classification. First one is your parametric models, and second is your non-parametric. Now, parametric, where you have a certain fixed number of parameters, like your linear regression. Like if you have four independent variables, you can only have four parameters. Doesn't matter your data is 10 sets, 20 sets, 50,000, or whatever, your parameters won't change. Now, if I talk about non-parametric models, here the parameters will change. Now, these are tree-based models or neural networks. Now, why do we call them non-parametric? Now, for example, if you have 100 records and you're building a decision tree, if you have considered depth as 2, your parameters will be different if you make depth as 4 or 5, because that way your tree will go deeper and it will generate more parameters. So parameters, or I would say an initial function, is not fixed in non-parametric problems. Any questions so far? I know this has been a little technical, but this much is required. So I'll take a pause here for 5 minutes. Feel free to put your questions here, any type of questions that you have. Then moving toward my last slide, which is data science for business. You know, I I have been particularly working with business stakeholders to solve their business problems using data science. And there is another field of data science which is for the products, where you integrate your models with the product. Now, for example, if you must have you, I mean, if you have used Amazon, you must have seen when you buy X product, you get a recommendation saying that you may also like this. Now, that's the integration into product. So let's move. Let's talk about data science for business. You can actually solve a lot of problems. I've just put, like, like the 4 or 5 areas here, starting from sales to finance to IT support, distributors, and then customer engagement. Now, various problems in sales, like propensity models, where you're going to predict that this particular customer is going to buy my product or not. If you're a big company, you have, let's say, 10 lakh customers. So every quarter, you cannot go to 10 lakh customers. You need at least, top 10,000, top 20,000, where you can go, and who are more likely to purchase your product in that particular quarter. Now, that's where machine learning and data science come into picture. Churn, if your customers are leaving and you want to give them discounts, give them offers, so you cannot give your discounts to everyone. You have to focus on certain customers who are big customers and who are leaving you for XYZ reasons. Then if I talk about recommendation system, I just talked about the Amazon and Netflix problem. Even in Netflix, you may see that they would be a tab saying recommendation for you, that you can watch this or you may like these things. Now these are solved using your historical data, the region you are in, and your peers around that region. Now, for example, if I give a small example, when this movie was launched, a robot, a robot 2.0, where we have Rajikant sir and we had Akshay Kumar sir. So in North, Netflix was showing the the charts in the app where Akshay Kumar had a bigger poster. He was, had a bigger image. Where in South they were showing Rajnikant sir with a bigger image, because people are more likely towards watching the movie where they have Rajnikant sir in South India, and people are more likely to watch that movie when you have Akshay Kumar as a bigger, I would say, in the bigger area, as a bigger picture in it in the app. Now these are the small things, that can actually help us you to have more engagement, more personalized recommendation to the customers. Now, if I talk about legal and finance, you can actually solve a lot of fraud problems, a lot of fraud payments, a lot of contract problems where you have, some. See, if I talk about contract problems, to be specific, a contract is like 100 pages, and any human can make error when they're reading it. But if you feed it to machine learning, and if we say that we have to identify non terms that are actually not suitable for our contract, machine learning can help us to do that, and that too within seconds with a high accuracy. That's where uh, we can actually help business to solve their problems. If I talk about IT support, some of you, if you have worked in support, you would know that we get support tickets a lot, and sometimes we manually have to categorize it, saying that this is particularly a data problem or an input output problem or a timeout problem. So if we train a particular model that can help us categorize those tickets based on the text, based on the complaint of the ticket, and we won't be able to, we won't have to spend so many manual hours on that. And then if I talk about partners and distributors, then see, in B2B business, companies don't go directly sell to you. Now, for example, if you're buying, let's say, uh, Windows from Microsoft, their salespeople won't come to you. You will probably buy Windows from their website, or when you buy a laptop, let's say from Lenovo or HP, you will get the Windows directly. Now, they act as a partner and distributor to Microsoft or any other company for that matter. Now, we need to understand which right product should be sold by this distributor so that we get maximum revenue. Now, these are the problems that can be solved by data science and machine learning. So I hope I was able to convey the message that what exactly data science is, what are the things in data science, different roles in data science, what is the depth and breadth of data science, and what are the different use cases, business use cases that we can solve using data science. So that's all from my side. I have actually put my LinkedIn and my email links here. Feel free to connect, feel free to ask questions. Okay, we have a question from Amrendra. I am working accounting analyst. What are the opportunities in data science for me? Okay, see, if you're working in accounting, there can be problems where you have many journal entries that can mismatch, that can be called as anomalies. So so you can solve those journal entry problems. You can, uh, if I if I understood the questions correctly, in accounting, for example, you have uh, your I think your debit what comes in, and credit what goes out, and then you have assets and liabilities. There must be a range, where you could accept the variation. But if that variation is going high, you would have to raise a flag and you have to say that there is some problem. So that variation, how much variation can you tolerate, that can be solved using data science. You can actually build a normal distribution of your data and then you can see how many of them are actually beyond plus minus 6 sigma. That can be your one of the areas that you can see, and anomaly detection problems that you can work on. And if you are into accounting, probably you can see that what are the customers who can come to you for your accounting solutions, or solve their accounting problems. So you can build a propensity model also for your customers, that these are the customers who are more likely to come to you but not to your competitor. I hope I was able to give some light on this. Any questions? Let this be a proper conversation. You guys can ask me anything, because I started as a non-data science, and then I was into support, and I mean IT support, and then I moved to data science. So I can understand the questions that you guys would have. And what I believe is that no question is stupid or no question is simple. Every question has some meaning, and I have asked a lot of stupid questions in the past. So that's what I believe in, that no question is small, no question is silly. Every question is important. So feel free to ask your questions. Okay, so I'll take it as a no. Thank you so much, everyone, for this session. You have been a great audience. I'll attach this PDF. Feel free to go to it. Feel free to connect with me over LinkedIn or email. Yeah, thank you so much. It's been great talking to you people. Bye bye.